The Harris Corporation has presented several times before. Harris Semiconductor in particular, which is a sector that we've been working with for quite a while. Ray Ford, Director of Plant Operations, Mountaintop.
Morning. Everybody's recaffeinated here, so you're alert and alive again, I'm sure. As Dee mentioned, I'm the Director of Plant Operations for Mountaintop, Pennsylvania, which is a long-winded, overbearing way of saying I'm a plant manager. As Dee mentioned, what I'd like to discuss today is the results of our work on Project Raptor in Mountaintop, Pennsylvania, a very ambitious project to build a wafer fabrication facility. I'll discuss a little bit about what that means, what that took. And basically, the paper is focused on the application of the theory of constraints to project management, the critical chain approach to project management. I'll briefly go through, and Dee said make this real brief. I think she said, Ray, they know who Harris is. Don't put them to sleep with this chart again. Harris is a $3 billion corporation, high technology, heavy engineering content, headquartered in Melbourne, Florida. More specifically, the semiconductor sector of which we are a part, and this project is based, our project was based in Mountaintop, Pennsylvania. That's where we do all of our power discrete manufacturing worldwide. It has a sister facility in Kuala Lumpur, Malaysia, where back-end processing and test is done. Very large facility. The Malaysia facility is some 4,000 people strong. The Mountaintop facility is about 850 people at this time. Does about $300 million of business at this time. The project I'm going to discuss, Project Raptor, encompasses an interaction between both of those sites. By way of background, a little more detail about Mountaintop. It's a 30-plus-year-old facility, previously owned by General Electric and RCA, so it's an acquisition by Harris Corporation. In a commodity business, discrete power semiconductors is the low end of the food chain in the electronic component business. High volume, 20 and 30 million units a month, low cost, average selling price 40 to 50 cents. Classic follower philosophy, we were in a commodity business. We were not much of a factor, we were me too. Our strength was we had significant volume and quality capability, but we were not leaders in market share, technology, or market leadership. 4 years ago, we dispersed DBR and SFM extensively throughout the plant. We currently have 4 Jonahs on site in Mountaintop. I am one of them. 3 of my staff are also Jonahs. We do have a Jonah on site in the Kuala Lumpur facility, our back-end operation. And in the last month, we've added Jonah to our marketing operation to further exploit our marketing opportunities. Dee mentioned briefly in September of '95 in Philadelphia, we had a presentation on the DBR results and what that had done for us in the Mountaintop facility. I'll summarize those briefly in a minute. And if you were in March of '96, you were in Washington, D.C., you heard about the ambitious look we had taken at the Raptor project and the translation of what is 30 months in our industry as a typical norm, and what we believed we could do with that, and I'll report today on what we have accomplished so far. The market we're in, again, is a market that's currently growing rapidly through the end of the decade. It's growing at 10 to 20% a year. It's a very large market, a few $1 billion. It's coming through a bust cycle. If you're not a strategist and you're a tactician, the last 13 months have been tough. The decade's been great. That's a little bit of the cost world and the throughput world right there for you. There have been very moderate adds to capacity around the world in this industry. Why? Because it's tough, profitability is marginal, and people are reluctant to invest significant capital in an industry such as ours. The comfort factor is not very high. In summary, the 4 years that we applied the theory of constraints to DBR, we had some significant improvements in our operation and our business. The industry I mentioned grew at 10 to 20% a year for the last 4 years. Harris grew at 40. The implication is we didn't grow with the industry, which was our historic norm. We grew with the industry, and then we took some market share off some people who fall into the second line of that statement over there. So we're coming off 40% a year growth. In an industry where 3 inventory turns is considered pretty damn good, and that's with apologies to anyone in a better industry than ours, we went from 2 to 7, on our way to 10. So we turned our inventory turn position into what is considered world-class in our industry, 7. People have written a book about a company in our industry that did 7 turns. We're currently at 7. We expect to be at 10 within a year. Our profitability, because Ellie was going to ask me about that anyway, over the 4-year period went from we didn't have any to last year we generated 80% of the profits of the whole semiconductor sector. We generated 20% of the profits of the corporation. That immediately made me want to go and ask for a mortgage to do some constraint elevation. All of that, by the way, took place in our existing facility with modest capital adds for capacity. So that was just classic synchronous flow manufacturing and DVR, making use of what you have. We then wanted the opportunity to elevate that constraint and add significant capacity. You'll forgive me if I call FAB 8 and Project Raptor the same thing. The nickname we gave this project was Project Raptor, and it's so much damn more interesting than the words FAB 8 that I defer to it at almost all times. Some interesting facts about Project Raptor. It's a global project. It's a pipeline project. I mentioned we manufacture 2/3 of the process in Mountaintop. The other end of the pipe is 12,000 miles away in Kuala Lumpur, Malaysia, where it has to be assembled and tested and shipped to turn into true throughput. So when I talk about this project, it in fact includes building activities, equipment activities, and people activities in a 12,000 mile long pipeline. It's the single biggest investment Harris Corporation has ever made. It's a $250 million investment. Harris is a 100-year-old company, so it is not insignificant that they chose us to invest $250 million in. It is more significant for those of you familiar with corporate culture and corporate world that this is being invested in a facility that they purchased. This is not a Harris facility by trade. It's an 8-year-old Harris facility. It's 37 years old as a facility. It's a facility that they're investing in, not at headquarters. I flashed up a chart. They have manufacturing capacity for semiconductor at headquarters. There was a discussion about putting it there. The decision was made to put it in Mountaintop. And probably most significant, certainly to our first speaker today, it's a union facility. It's a union facility in a corporation that has 90% non-union people. So it was fairly impressive that they chose us. President of our sector, John Garrett, said that when you make those kind of investments, you base it on people. That was certainly an eloquent thought. I would submit to you, anybody who's been around a corporate meeting, they don't invest in anything except the numbers. 7 inventory turns, 80% profitability, and 40% growth. I'm not that nice a person. I'm not worth. My family wouldn't give me $250 million. But it was a nice thought. The project went on full speed. The project, first of all, doubled our capacity. This was not a follow the market, follow that 10 to 20% growth rate. I mentioned we have been growing 40% a year. This doubles our existing installed capacity. This is a play-to-win strategy. That is a strategy that John Garrett, the president of our sector, does espouse and does live up to. Anybody who gives you a $250 million bet is playing to win. He's not at the slots. Duration of the project took place during the probably worst 13 months in the semiconductor industry history. At least that's what the electronic rags have touted the last 13 months of our industry. Remember, growth through the decade was 10 to 20% and healthy for all, but the last 13 months was hell. The project management at corporate stayed committed to this project for 2 reasons. The easy and obvious one is they were thinking 30 months. Project done. and I'll show you some results on that. So we were ahead of corporate expectations. If you've been around corporate, their commitment remains firm as long as you are ahead of their expectations. If you get close to their expectations, commitment wavers. And if you get below it, you've got to stall the project. The second reason was it moved so fast. Speed is everything, in many senses of the word. It moved so fast that by the time they got around to even thinking about whether they should stop it, it was done. They did. There was a discussion 10 months into this thing. Like, what if we stop? And I said, gee, we own everything. We got a building, the equipment's in it, we've hired the people. What would we say? Even the cost accountants couldn't come up with something for that, and they tried. In fact, they tried for about 3 days to figure out how that happened. So we got our mortgage, and we got ready to start our project. And the first thing we did was a PERT CPM with the project. We did that because that's extremely popular at corporate. It had some pluses, it had significant minuses. The plus was it got a core group of people together, which I'll talk about in a little more detail, and we really got a good feel for the scope of this activity, this large undertaking. It generated 5,000 or 6,000 or 7,000 individual tasks, like a good PERT chart does, all of them equally weighted, by the way, and all of them equally important. And it gave us a feel for how hard this was going to be. It also generated the world's best high-tech wallpaper. If you're an engineer, you can do a conference room with the PERT chart for this project. You could also get real discouraged about why they didn't take more than 30 months to get a project like this done, so we decided it was interesting, but not the way we were going to approach the project. Dee joined us right around that time, became our mentor along with the Institute and Ellie on this project. And we approached it from the critical chain approach, the TOC approach, the throughput world approach to this, and said, what is the critical chain? The definition in this case being the longest sequence of dependent events in a project that we really have to do to deliver here. And that critical chain came down to be, we've got to build a building, I should say constructions, because there was some construction being done in Malaysia at the same time. That's an error on my part. Install equipment, both here and in Malaysia, to achieve this. And qualify all the product and ramp it into production. Turn it into throughput. Now that's a big disappointment, by the way, if you're an engineer who got $250 million to build a building. Because building a building is too damn much fun. You love to do it. You love to install and buy equipment. Engineers love to do this. I'm an engineer, by the way. Love to spend money. Engineers are reluctant to turn money investment into throughput because that's where the work starts. If you're an operations guy, that's where your fun begins, right? This project, as it was defined in a PERT chart, was to build a building and install some equipment. When Dee got done with this critical chain, it was a project to ramp a facility into 90% of its production output, so it was paying back that mortgage. A little bit different perspective with rather significant implications. We did establish a cross-functional core team of people. We did something pretty interesting with this. We made the architect and the construction manager, as well as a group of people with us, our core team. Architects and construction managers usually meet if necessary. They usually require a referee. We had a core team inside the plant that included human resources, horror of horrors, cost accounting for an educational purposes, MIS, and several other activities not usually associated with a building. The building usually belongs to the engineers until they're ready to turn the key. And then someone finds out that they didn't put adequate parking in the place, that the MIS systems aren't up to speed. So we had a very interesting guidance and discussion with Dee on how you get a real core team focused on that. We also told our construction firm and our design firm that we really wanted this thing in 13 months. Now they'll tell you anything when you're given that kind of money. And they said, we'll try. And I said, No, we want to do this as a real partnership. We want to hear what we have to do that. An example of the kind of things you have to do that is, they said, well, in 2 weeks we have to start to put the foundation for this building in. You haven't laid out the tools, you don't even know exactly how big the building is. So I said, well, in 2 weeks we'll know. Pretty much we'll know. In 2 weeks we did. In another 2 weeks they needed to know a tool layout, and they said, we can tell you people bigger than you work 1.5 years on the tool layout and they still don't have it right. And being an engineer, I knew the answer to that question. The tool layout is never right. The tool layout is good enough. Dee educated me on that. So we did work closely with them from the beginning and allowed them to challenge us with what you have to do to make something, you build something in 13 months. You can build a building in 13 months if you really want to. We applied TOC management techniques for the project. We did not do daily buffer reviews. We did do critical chain monitoring religiously. We defined this critical chain, and we as the management team religiously monitored the critical chain of events. As importantly, we did not monitor everything else we subordinated to the critical chain. We did not say one thing and act another. We did not drive the management group that was running this core team crazy with anything that wasn't related to how you're doing on the critical chain. There are, and I'll discuss some examples, there are an infinite number of things you can discuss not related to the critical chain, and people will discuss them with you, and people will go out and research them, and people will slow a project down doing it. I mentioned D. Jacobs and the good enough approach. Those words became the watchword of the project. Those of you not familiar with the critical chain approach to project management, we installed a project buffer. What is a project buffer? It is the strategic safety accumulated at the end of the critical chain. It's designed to protect project completion date. It's the cum of all those tasks we identified in the critical chain, but put at the end. Put at the end the buffer is. This project had a buffer of 60 days. It was completed 3 days ahead of schedule. 40 of those days were consumed in the worst winter in the Northeast in 100 years. I'm going to take offers not to build buildings in the Northeast anymore based on weather predictions. We reacted to that, by the way. It was in the critical chain. We reacted to that by authorizing overtime so that they made up a portion of those days as best they could. That was in the beginning of the project, interesting to note. 15 days of the buffer was consumed right at the end of the project. We had an equipment installer default on their commitment for resource to when they could install equipment. We reacted to that one very vigorously. We threw that guy out, brought in another guy. He defaulted on a bond he had posted. Went to 7 days a week around the clock to pull the equipment installation back in. However, we did come in 3 days ahead of schedule. Another technique in critical chain is to have feeding buffers. What are the feeding buffers? Just buffers that are used to decouple any paths from the critical chain. Subordinate everything else that you have to do, and there are plenty of things you have to do to have a facility ramp to production besides the building, equipment, and qualification. Hiring and training was an interesting thing that we subordinated from day one. We had that all wrong. That's cost accountant mistake number one, the road to hell. Don't hire anybody till you absolutely have to because you have to pay them salary. We got into this with Dee and went through that and said resource contention is a big issue in a project of this undertaking. We want all of the hiring and training of everyone who's going to work in that building to be done by the time the end of the building is finished. And that's before the equipment's been delivered and before you started the process up. We did that. We did that. We did a feeding buffer of 8 months. 8 months before we had this thing making silicon, we had everybody hired. Now the 8 months seems long. I will tell you that part of the hiring was the core team was pulled from an existing facility running at full speed, 7 days a week, 24-hour day operation, this is, by the way, all of these. And we pulled 90% of the core team out of that operation. We said, you can go work on FAB 8 or Raptor as soon as you cross-train, hire and cross-train your backfill. You cannot lose any momentum on the existing operation. No throughput can be lost. That does tend to take quite a bit of time. We hired field service engineers from vendors. We got them as part of buying. It's amazing. You buy a couple $100 million worth of equipment and they even throw in some vendors for you for a year for free. to support it. We hired them and we said, cost world would be, don't bring them in until that equipment's here. Get your money's worth out of it. Brought them in 2 months in advance because these people had to move here, move their families, buy a house or rent a house, get settled in, and would not have spent any time working on your equipment for the first 2 months they arrived, whether you wanted them to or not anyway. I talked about raw material supply. This was the material that didn't exist at the beginning of the project. We worked directly with a vendor on that, a single vendor. We told them, you are our strategic partner. You will get 90% of the business that we give to a vendor for raw materials. They developed the first 8-inch wafer for us. Finally, we also addressed resource buffers. Buffers that are designed to ensure that resources needed to work on the critical chain are available when needed. That famous PERT chart contention of someone's working 0.2 of their time on something and 0.15 of their time on something doesn't cut it. We had two major components of that. One, we had our contractor take care of a big piece of that on all of the subcontractors. We said, you're going to manage them, they're your responsibility. We didn't have, with the exception of the one default, didn't have any contention issues. The other part we had was internal. We evaporated resource contention during equipment installation and product qualification. We did something pretty interesting with the equipment here. You can't have the equipment ramped up in 13 months if you wait for it to get here to qualify it and to train everybody on it. So we trained all of our operators, technicians, and engineers on our equipment at our vendor sites around the world, and in fact qualified the first processes there. All we did was verify those processes when we started our tools up when they were delivered. Cost accountants love that. Before I go into some specific detail results, I just want to talk about a global look at this project. Our first and foremost priority was the scope of the project was fixed. We said we were going to do enough capacity to double our business. That's what we have. That's what we installed. Those of you, as I have been over the years, who have been associated with projects that don't work, one of the easiest things to do is just revise the scope of the project. In technology industries, there's an excuse a minute to do that. The excuse we've had in the last 12 months is a new technology's been invented. We could have said, well, because there's a new technology associated with this, we'll need another 6 or 8 months on this project. We fixed the scope. We fixed the duration. We made it real clear that we wanted to do this in 13 months. As I mentioned, it came out 3 days early on silicon output. It's about 15 months ahead of industry average on production ramp as well, and I'll show you a little bit about production ramp, dollar days. Project's a third ahead of corporate expectations, and that's not because corporate has low expectations. No one gives you $250,000 with low expectations. In fact, they have very high expectations, but it's all based on what people have done before. They want it paid back real quick, too. Project was semi-variable. The budget was semi-variable. We were 4% over on budget. Big budget overruns. Lots of discussion for about a week on that until they saw the rest of the results. The real irony of a cost world approach to budget is, anyone here familiar with what the projected overrun would be on a project this size at a corporate level? 10% they consider a direct hit. 5% you get a gold star, I think. We were 4% over and we didn't even pay attention to it. Time to complete, Dee mentioned, 28 to 36 months is the industry average. The facility is now producing and selling product in 13. This is the 14th month we are in right now. Last month we shipped our first product out. Time to ramp the production facility, that's to use 90% of the installed capacity. That's a pretty ambitious undertaking. We want to use 90% of the capacity we paid for in 21 days. There's an easy way to do that, and it's called applied DBR thought processes. That's complete. We have done that. It usually takes, and corporate had written down, the best the industry does is 18 months from the day you've got a qualled, installed production facility written on a granite tablet somewhere is the fact that you can only ramp it at so many wafers per week, and that takes 18 months in this case. So that's the significantly ahead of corporate expectations on dollar days. Selection, hiring, and training. Everybody, 100% of the employees, as I mentioned, were hired 3 months after the project started, 13-month project. 8 months after the project start, before we had equipment, we had them all trained on the equipment because they went out and found out where the equipment was. It wasn't even here. 12 months after tool installation is when people would have hit that same hiring and training milestone. Cost World would have said, get the building, get the equipment, then hire some engineers and technicians. Then about 3 months after that, hire some operators who are actually going to run this stuff. And 12 months later, you'll have a running facility. Just as important and often overlooked was, and I had mentioned it earlier, we maintained existing throughput in all 3 wafer fabs. So we maintained the output of these facilities, the older facilities, where we took 90% of the core team away, at full capacity. These are facilities that, once again, run 7 days a week, 24 hours a day, and have fully utilized. Another interesting thing we did, which is a application of a little bit of TOC training to the marketplace, was we went out and put together a matrix and a plan and convinced all of our customers, we have about 5,000 customers, that 6 months after we had our first product qual, any one of those customers has agreed to buy any one of the products we make. We make about 5,000 products, too, by the way, from that facility. We marketed that facility. We marketed the qualification of that facility. And in 6 months, right around the June, July timeframe, we will make and sell to anyone we deal with any product we make in our existing facility. Now, who do we deal with? We deal with Ford. We deal with General Motors. We deal with Bosch. We deal with Siemens. We deal with the federal government in some cases. We deal with some pretty tough customers. They have bought into this. I said I'd get back to dollar days. Remember that horrible 4% budget overrun we incurred. That unforgivable 4% budget overrun. And it was unforgivable if you were a cost accountant. Here's the corporate expectation, AOP scenario, of how fast we could ramp that facility and turn it into dollar days and pay back their $250 million mortgage. That was based on the best the industry does and all the knowledge they could find. That was not because they were nice people and wanted us to give us a break. They knew we were working hard. Here's the TOC payback scenario after 21 days that we're into right now. It's roughly a square, and it's roughly 2 times faster payback in terms of dollar days than they were thinking of. So I'm paying them back twice as fast. The facility came in 13 months, but they still are trying to figure out how that happened. And I'm 4% over budget. Do you think they're mad? They're not mad. People between corporate and us might be mad, depending on what department they work in. Corporate is not mad. Where do we go from here? Well, we got to exploit that constraint, twice the capacity. Marketing programs, the most recent Jonah added to our operation, and that's within the last 60 days, I believe, Dee, is a marketing person to help exploit that. And we are helping exploit that. We are marketing this facility. We're turning it into a marketing tool. We're flying 400 executives in from Europe, Asia, and North America to see this facility, to tell them how fast we built it, what it's capable of, and ask them who they're buying product from that does this kind of work. The next interesting thing you're liable to hear about in another couple of Jonah sessions is we're applying this technology now to new product development. We've got our design activity, which is co-located in Mountaintop and has not been part of TOC so far. And we're going to use critical chain, project management, to introduce 200 new products from Harris in 18 months. The industry norm and the Harris best ever practice is 20 to 40 new types a year. So this is about a 500 to 700% improvement in rate of new product introduction to exploit this capacity constraint that we have and to take more market share. After we get this mortgage cleared away, we want to elevate the constraint again. It occurred to us as we went through this that building one wafer fab at a time is inefficient. It's time consuming. We're probably going to build 3 the next time. It also occurred to us as we went through this that we made some mistakes. So 13 months was a good, Dee would say was probably a good first start for us. We probably can go 30% faster than that on the second time. Special acknowledgments. I always acknowledge anyone who loaned me $250 million for any reason, any time. Anybody here has money, I'll acknowledge you right after this or publicly. The FAB 8 team of people who had, I heard the term whatever it takes, and we use that as well. We're in trouble. We're going to get copyrighted by, I see Digital Equipment now has it as a major ad campaign. D. Jacob for guidance and encouragement, and of course Ellie for his vision and support of Harris over the 4 years. I would point out that there's a feedback effect here. This is only here because of 7 inventory turns, 80% of the profit for the sector, and 20% of the profit. I'm not that nice a person. They would not have given me on personality and winning appeal. Before I take questions, Dee reminded me of keeping an eye on me. He reminded me of 2 things I forgot to cover. One was what did we do about designing this new facility for loading? Traditional industry norm for semiconductor is to level load a facility. Lightning should strike somebody who knows about TOC and DBR like we do in our existing facility. So we chose a non-reentrant bottleneck that we designed into the back end of the manufacturing process, very near to the end, and ran with that. The other thing she reminded me of is before we applied our first application of critical chain to what was going to be the critical chain for this, as it was being misapplied at that time, was people and hiring and resource was actually going to be the critical chain item that was going to cause this project to take 30 months, and with her help, we subordinated that almost immediately. Questions?
How did you obtain your building permits, and if you have emissions, how did you get your EPA permits?
The question was, how did we obtain building permits, and with emissions, if we have emissions, boy do we have emissions, we don't miss anything in semiconductor. How did we get permitting? We met with the governor of the state of Pennsylvania and explained our dilemma, and he shared his concern with our dilemma. Didn't want it solved in Florida, for instance, as a place to resolve that dilemma. So we got on-the-fly building permits and emissions releases, temporary emissions releases, all consistent within the law, but all directly related to how interested people were in working the law to the limits. So we did that.
You also built a new sewer system.
We also put a new sewer system in for the town as part of, we are their major contributor. So part of that overrun of 4% was a sewer line. Other questions? Dee has one.
I seem to recall at the March 96 Jonah upgrade workshop, not the timing you talked about today. And I don't recall in the original planning meeting 13 months. I think it was 18 months. So the 4 days early is a little bit deceptive. You want to talk
Yes.
a little bit, 3 days early is just a little bit deceptive. It sounds to me like it's a few months and 3 days.
That's, you're totally correct. I'm my own worst critic. So when I describe expectations,
Besides me, right?
besides you, so when I describe expectations, I agree with what we came up to as our revision. 18 months is what we committed to the corporation, and they quite frankly didn't believe 18 months because their industry data said 28 to 30. So when they factored in the payback analysis, they took it out past 18 months. So Dee's right, it's 3 days and 5 months. And based on what we know now, it's 3 or 4 months late. Excuse me, I'm sorry, someone had their hand up first.
In your cost estimating, how did you go about estimating costs for activities related to your buffers?
In our cost estimating, how did we go about estimating costs with the activities related to our buffers? We didn't. We reacted to, you mean like hiring people early and stuff?
Specifically, the buffers don't have specific activities associated with them. Is that cost overrun associated with those activities?
No. Let me try and answer your question again. The cost overrun specifically was related to the fact that the building turned out a little bit larger than we thought it was going to be. And that was just because we didn't know at the time. The last time we built a building was in 1960, so we were a little rusty. We tracked cost and we subordinated it to what was required to make this project meet its full scope and be on time. So we did not do a lot of work trying to allocate cost to the buffer activities or understand what the costs of those would be. We just did them. And then we monitored our cost. Lord knows it was monitored. We had a lot of help monitoring our cost.
Was there a parallel effort going on in terms of how to use that doubling of capacity, in terms of making sure that the market didn't become your constraint for at least very long?
Yes. Yes, there was, because as we got into the project and we expanded its scope, I mentioned the scope of the project went from, in PERT CPM days, build a building, install some equipment, and qualify it, to ramp full production. Right after that, as we went through that with D, it's now you've got to turn this into throughput. Everything's got to be throughput.
When you are saying that expectation of the standards is 13 months, 3-0, you are including building the building and putting the machines in.
Yes.
Do you include in these 30 months wrapping up production to 90%?
No.
No. So the way to compare the 13 months is not to the 13 months that you have, it's not to the 30 months, but to
54 months.
54 months. Thank you.
What specifically did you do in terms of that market constraint?
In terms of the marketing strategy, that last foil I had hit a few specifics. First and foremost, we had our first ever marketing Jonah scrambled up to the Institute on 48-hour notice. Secondly, we turned the facility itself into a marketing tool. I mentioned that. We're bringing 400 execs, flying them in from around the world to show them this facility, what we've done with it, and to tell them what we intend to do using critical chain on new product development. I mentioned 500 to 800% improvement in new product development rate. All of these things are valuable to a customer and indicate commitment and competency. So we made the facility a marketing tool. We did a brochure for our field sales force to hand out about the facility, about the capabilities. We did a film, which if we can get it edited through legal, will be all right, or get a waiver from Mr. Spielberg. And we are focused on, myself and my staff went in the marketing business because we could not let that be the constraint. We had to turn this into throughput. So we made the film, we authored the customer days, we are doing whatever it takes, there's that with all respect to digital equipment, to not let the market be our constraint. In fact, we are betting to win. We are going to take market share off somebody else. That quick and the dead quote. The market's not going to grow 40%. We are. The market's going to grow 10 to 20. Somebody's going to lose.
And it's working.
Oh, it's working quite well. Some of the most eligible to lose are absolutely obsessed with this project. Absolutely obsessed with this project. You get all that Machiavellian kicks out of critical chain project management as well. There's a lot of sleep being lost on the West Coast.
I have a question. Is this on?
Sorry?
Oh, okay. Congratulations. It's phenomenal achievement. My company builds refineries, chemical plants, so we know how difficult that is to do. It's remarkable. I have a couple questions. You mentioned relative, the 13-month schedule relative to the industry. What about the cost? Did you pay a cost premium for the speed?
I would say no, because I said I was 4% over on the total project, and in the infinite autopsies you do for the cost accountants of where you spent the extra money, it was because we made the building a little bigger than we thought it had to be. So virtually all of the overrun was not associated with early completion premium. The builder said, I can build you a building in 13 months at this price. And the architect said, I can design you a building in 13 months at this price. What they were both thinking is, you guys will never get your act together internally to supply us with the information we need to do that, so what's the rush? But I'd say virtually 4% total overrun, which again, remember, that's a direct hit in the corporate world, because nothing moves that well at corporate, or is that accurate. 4% overrun, I'd say in excess of 3% of it was because we changed the parameters of the building based on knowledge we gathered as we went through building the building. So we didn't pay an early completion bonus. We didn't pay round-the-clock overtime or anything extenuating like that.
The $250 million, was that was established before you actually established your schedule target, wasn't it?
Oh, that was established, yes, that was established before any of those targets were in place. That was again, conventional industry wisdom of what a building that size to achieve that level of capacity should cost you.
All right, I have one more question.
Wait, I want to elaborate a little bit about that. $250 million project on paper. Would you accept before 4% overrun as something beautiful, or would you be afraid of 100% overrun?
No, I think our average is around, I think about 6% overrun.
And you are, talk to me, and you're which company again?
M.W. Kellogg.
M.W. Kellogg. How much of the overrun in your project is not called overrun, but called client change his mind and wants something more?
I'm not sure what that runs as a total of the percent, but I think about 10%.
Exactly. Now, compared to the 16%, 4% is beautiful.
Yes,
Don't justify the 4%. It's gorgeous.
I just had one more question. What was the size of your master schedule?
Size of our master schedule, you mean a per chart kind of blowout, or?
Yeah, the one you actually used to pretty much manage the project.
The wall, we dispensed with the wallpaper when we abandoned the whole thing and went to critical chain. The size of the critical chain wallpaper was D.
In other words, how many critical chain activities and how many feeding buffers?
It was an alarmingly small number of activities. Alarmingly, if you don't have a sense of adventure.
Some of you heard this the other day. We started the critical chain schedule with colored index cards. Some of you have been with cutout pieces of paper, and put a series of tables together, of which I was standing on top of them, moving them around with a stick like a World War II movie, the Admiral moving the ships. I think, John would say, probably like around 150 items. Yeah. And then it was broken down to the detail we needed at various levels. But that really, when we were all done with it, we were basically working off of about a 4-block diagram of managing the critical chain.
Yeah, I would say halfway through this project, it was a 4-block diagram.
Could you define 4-block diagram for us?
4-block diagram, let me tell you my questions on the thing for the last 9 months of the project. Is the building, the equipment, and the people on schedule? And if not, where? And what are we doing to fix it?
Plan, build, install, ramp.
Right. Now, I will tell you that my project managers wanted to tell me about a lot of other things. The outside, they wanted to tell me about the paving. Didn't care. Doesn't make wafers. Not part of the critical chain. They wanted to tell me about a lot of things.
Thank you very much.